Section 3.5 is solving quadratic inequalities. So to solve a quadratic inequality, we use a number line, and anything that goes on the number line is any value that makes the function 0 or undefined. For quadratics, there's nothing that makes it undefined, so we just have to worry about what makes it 0. In order to do these, you need to be able to solve quadratic equations. So if you need a little review, I would suggest watching the video linked above, 8.6. So here's an example, x squared less than or equal to 4x plus 12. Just like solving an equation, the very first thing you want to do when you solve a quadratic inequality is set one side equal to 0. So I moved everything over and you get x squared minus 4x minus 12 is less than or equal to 0. And then to find where this is 0, I'm going to factor this. So I'm going to use the diamond method. They need to multiply together to be negative 12 and add up to be negative 4. So you end up with negative 6 and positive 2. Because your leading coefficient is 1, these are your magic numbers. These are your factors. So you get x minus 6 times x plus 2 is less than or equal to 0. So if we use our zero product property, the numbers that make this 0 are x equals positive 6 and x equals negative 2. So these are the numbers that we're going to put on our number line. Because this is less than or equal to, we want closed circles for these because you can actually equal 0, so those are okay. And then we want everything that's less than 0. So to be less than 0, that means that you're negative. So I'm going to pick a number in each of these sections and figure out whether the function is negative in that spot or positive in that spot. So if I pick something less than negative 2, for instance like negative 10, you're going to get negative 10 minus 6 and then negative 10 plus 2. So negative 10 minus 6 or negative a million minus 6, it doesn't matter, is going to be a negative number. And then negative 10 or negative a million plus 2 is also going to be a negative number. So we have a negative times a negative, which ends up being a positive. So any value less than negative 2 plugged in for x is going to give us a positive y value. If we plug in something between negative 2 and 6, like 0, you're going to have 0 minus 6 times 0 plus 2. So 0 minus 6 is going to be negative. 0 plus 2 is going to be positive. A negative times a positive is a negative. So anything between negative 2 and 6 is going to give you a negative number. And then greater than positive 6, again like a million, you're going to plug something in like a million. A million minus 6 is going to be positive. A million plus 2 is also going to be positive. So this whole thing is going to be positive. If we want where the function is less than 0 or less than or equal to 0, do we want where it's positive or where it's negative? So less than 0, that would be negative, so we want this middle section in here. So our solution written in interval notation is negative 2 up to positive 6 with brackets because we want to include those endpoints. So graphing calculator interpretation, we have two functions here and we want to compare them. So over here I have graphed y equals x squared and y equals 4x plus 12. And we want to know where is x squared less than or below or smaller than 4x plus 12. So you'd find those intersection points, which would be negative 2 and positive 6, and you're looking for where they are. The red one in this case is below the blue one. So it would be this section, all these x coordinates between negative 2 all the way up to positive 6. So here's a second example, 2x squared is less than x plus 10. So go ahead and go through the same steps we did on the previous one to solve this inequality. So first I moved the x and the 10 over to the other side, so you get 2x squared minus x minus 10 is less than 0. Then this one I did factor again, but because this is a leading coefficient of 2, these are not your answers. You have to factor by grouping. So you get 2x minus 5 times x plus 2 is less than 0. So the zeros are 5 halves and negative 2. So if you haven't already done so, go ahead and put these on the number line and find where it's positive or negative and which section you want. So on this one I put negative 2 and 5 halves on the number line. Make sure you put them in the right order. On this one I have open circles because this is strictly less than, not less than or equal to, so the zeros are not part of the solution. So I pick something way smaller than negative 2, like negative 100 or negative a million, and you're going to end up with two negatives. This first factor is going to be negative, and this second factor is also going to be negative. A negative times a negative ends up being positive. If you plug in something between -2 and 5/2, like 0, this first factor you're going to end up with a -5, so a negative. The second factor you're going to end up with a 2, so you're going to end up with a negative times a positive, which is a negative. And then the last one, if you do the same thing, like +1,000,000, you're going to end up with a positive times a positive, which makes the whole function positive. We want where it's less than 0, so negative is less than 0, so we want this middle section in here. So if we write this in interval notation, we have parentheses, because we don't want to include, -2, 5/2, and then close our parentheses. So make sure whenever you're solving inequalities with the quadratics, you always set one side equal to 0 first, and then factor whatever makes this equal to 0 goes on your number line, and then you need to test each section to see what's positive and what's negative.